Welcome to this section. Our topic is the Linux directory structure. Recall that Linux is derived from the Unix operating system. One of the defining characteristics of Unix was this concept of everything is a file. That means that input and output involving resources such as documents, directories, hard drives, keyboards, and printers are represented by a thing that looks and behaves like a file. It may seem odd at first, but it greatly simplifies a lot of the programming within the operating system because it standardizes interfaces. It also means that locating and organizing these file-like resources is quite important. All these files and directories and file-like devices are stored in a file system. That's just a name for the organized structure, not to be confused with the low-level method of storing bits on a hard drive, which is also called a file system. We will refer to the high-level file organizational concept when saying file system. You are probably familiar with files and folders from Windows PCs or Macs. Linux has the same concepts. Folders hold files and other folders. Note that we sometimes say directories, so folder and directory both mean the same thing in this context. We will use those names interchangeably. The Linux file system is a hierarchical structure of folders with files and other folders stored throughout. Directory structures are often represented as trees starting from some root. The root in Linux is /, and it's a directory or folder. The branches of a tree are also directories, sometimes called subdirectories, because they are underneath or within a directory. Files are like leaves of the tree. They're the actual things that the tree is holding. In Linux, files can hold human-readable text, program-readable data, sometimes called binary data, or operating system executable programs. This is the root directory. Everything else on the file system is under or within this directory. There are more subdirectories under root than this illustration shows. Here we are showing the more commonly used directories, and in fact most users will only use one or two of these directories on a regular basis. /bin is the directory that holds many of the common terminal commands, which are individual programs that do some specific task. This includes commands like ls to list files and directories, rm to remove files or directories, and so on. We'll use all of these commands later in the course. /etc, sometimes said as etc and sometimes etc, is where we usually store configuration files that apply to the whole system. For example, our Apache web server configuration files are stored under /etc/apache2. /home is where user directories are stored. Each user typically has their own folder under /home, such as /home/bob. /lib is where system-wide library files, those are files which other programs depend on for certain features, are stored. It's also where kernel modules are stored. /run holds program management files. These are files that the system or some programs use to keep administrative and management data. It's generally not a place where users or even administrators mess around, but sometimes when you're investigating a problem, you'll need to look for or at a file in that directory. sbin is like the bin directory. It holds utility programs, but the programs in here tend to be more destructive or dangerous and are generally intended for administrators to use. Also, the file access permissions on these programs are usually restricted to administrator or superuser. The names are interchangeable. /temp is like /run in that it holds temporary data for programs or the system itself. Users can also read and write to files in this directory, making it a useful place for testing or dropping something for a short time. This directory is cleaned up automatically by the system. Details of when this cleanup occurs vary between different Linux distributions and even versions within one distro, but you can assume that files in /temp are safe for one day or until the next reboot, whichever comes first. /user directory holds utilities and applications that are typically considered to be extra or in addition to the built-in features of basic Linux. Within /user, there is a /user/bin subdirectory that has tools and utilities much like the main/bin. /var is for variable data, that is, data created and used by system services and programs like databases, web servers, etc. Of significant note is the subdirectory /var/log, where many services write their log files. This is a place you'll go to sometimes when you're troubleshooting or you just want to know what a particular service has been doing. For example, the Apache web server access and error logs are stored under here. There are a number of other directories, but they're not really interesting unless you're digging very deeply into the workings of Linux. Before we can start playing in the terminal and exploring the directory structure, we need to understand a couple of things. The shell, that program that runs in the terminal and interprets our input, does something hopefully useful with it, and then shows the output result. The shell gives us an indication that it is ready for input by showing what is called the command prompt. The appearance of the command prompt can vary, and in fact you can customize it to your personal preference, but in general it is there to indicate that the shell is ready and waiting for our input. The typical default prompt shows which user we are logged in as, what directory we are currently in, and what permission level we are at, user versus administrator. Here's a look at the standard bash prompt in Ubuntu on our Cloud9 system. We see the current user, a colon divider, the current directory, and then a $sign. The $sign is usually used to indicate that we are operating at the standard user permission level. If we were logged in as administrator, aka superuser, the symbol would be a hash or pound or $sign depending on your preference. And then beyond that symbol there should be a cursor of some kind, maybe a solid block or a flashing block or an underscore or something. Once you start typing, it begins showing from this point on the line. When moving around in the shell, two common commands are ls and cd. ls lists the contents of a directory, and cd changes which directory we are in. Depending on settings of ls, you may or may not see an extra symbol at the end of names in the output list. That extra symbol is the file type indicator. It's just an extra visual thing to help us, the user, see what type of file we're dealing with. If a file name ends in a /, that means it's actually a directory. If it ends with an @ symbol, it's actually a link to another file. If it has a star or asterisk at the end, it's an executable script or program. The Cloud9 shell automatically shows this type indicator, but other Linux distros may not show it by default. To show it, just add the $F argument to the ls command. I'm personally not accustomed to having that automatic, so I tend to still type ls --F as a habit. Here are some examples of changing directory and listing files. We go to the /home directory and then list the files there. Based on the output, we see that there is just one directory here. It's called Ubuntu, and it happens to be our home directory for this user. Dot and double dot are two special names that are used to refer to the current directory and the parent directory, respectively. If you're in a directory and you want to change to the parent directory, that is, the directory that this current directory sits within, you would type cd /return. Of course, if you're at the root directory, it won't go anywhere since the root directory is already the top-level directory. The Linux file system has a lot of files. A typical Ubuntu install has over 100,000 files, and this Cloud9 installation has over 400,000. It has so many extra files because it comes with a lot of extra things pre-installed. But we only care about a few files and directories. As a user, it's pretty common to not care about other stuff until you need it. Once you need it, you'll find it by way of reading some manual page or info page or Googling for help. StackOverflow.com is a good place for info, and more specific Unix and Linux questions and answers can be found on unix.stackexchange.com. Also, since this is Ubuntu, you can find good help on help.ubuntu.com. When changing directories, or even just referring to some directory or file, we have two methods of naming things. We can use an absolute path name or a relative path. With an absolute path, the name starts from the root. For example, to change to the home directory under root, we can type cd /home return. This command will work no matter where we are because we're giving the new location in complete or absolute terms. Usually we use absolute paths when the name we are referring to is far away from where we currently are. Relative paths are names relative to where we currently are. For example, if we are in /var/log/apache2 looking at some log files, and then we wanted to go change a configuration setting in /etc/apache2, we would probably use an absolute path. But if we just wanted to move one directory up or down, such as moving to the parent of the current directory, or instead moving down into a subdirectory, we would use a relative path. The visible difference is that an absolute path will begin with a slash, whereas a relative path will not. Our shell prompt should be showing us which directory we are currently in, but we can also use the pwd command to explicitly print our current directory. We discussed dot and double dot, but here are a couple of examples. From the last slide we were in /user/local, and now we cd space ... return. This takes us up to the parent directory, which is /user. pwd confirms this. If we cd ... again, we see that that takes us up to the parent of /user, which of course is / or root. Most Linux commands that use file or path names will work with absolute or relative paths. We've used both with the change directory command, but it's also common to do with ls. ls space /user shows us the contents of the /user directory no matter where we happen to be at the moment. Likewise, ls space ... /lib shows us the contents of the lib directory next to the directory we are in. A directory next to another directory is a sibling directory. Of course, that command is only going to work if there is a lib directory at the same level as the current directory that we are in. Usually you would do something like this when you know your way around a particular directory structure and you want to quickly look at files in a different place. Okay, ... seems reasonable and useful, but what about single dot? Doing a cd dot does nothing. But cp, or copy, requires a source and a destination. What if you need to copy a file from someplace to the directory you're currently in? You could specify the absolute path of your current directory, but that's extra typing, and Unix people don't like to type much. That's where the single dot comes in. In this example, we copy the Apache configuration file using an absolute path to reference it, and we copy it into our current directory by using just the single dot. There are other times when you might use the single dot. For example, if you had a program that had the same name as a system program, it could be that typing your program name would execute the system version of that program when you actually wanted to execute the version that was in your current directory. In that case, you would reference your program with /program name. That would be a relative path that clearly identifies the one you want to use. There's another handy shortcut that's similar to dot and ... and that's the tilde character. Some people call it the squiggle. The tilde represents the current user's home directory. As we see from this example, the cd command to /home/ubuntu takes us to the Ubuntu user home directory via an absolute path. Assuming we are logged in as this Ubuntu user, we could just type cd space ~ return. That would give us the same result. The tilde can also be used, as on the previous slide, when copying files or doing other things. Basically, anytime you refer to a file with tilde/something, that is providing a relative path that starts from the user's home directory. I mentioned earlier that shell prompt is configurable. Cloud9 has chosen to make their prompt different from the standard bash prompt. The standard default bash prompt shows the current username, an @ symbol, then the current host or machine name, a colon, and then the path. You'll also notice that when you're in the home directory, the shell prompt will show the abbreviated tilde instead of /home/ubuntu. There are many different ways we can list the contents of a directory. The standard way just lists the names. And as mentioned before, the -F flag tells ls to show the file type indicator. If we add the -L flag, that tells ls to show us a long listing, listing the files one per line and showing a lot of extra details about each file. This long listing shows file access permissions, which may not make sense right now, but don't worry about that. Who owns the file, which group owns the file, what the file size is, when it was last modified, and its name. Here's a breakdown of the long listing. The file access permissions we won't worry about in this course, but those first R and W mean that the owner of the file is allowed to read and write to that file. The next number is an indicator of file lengths, but you can ignore that for now as well. Then we have the username of the owner of the file, and following that is the name of the group that owns the file. Groups are named collections of users, so that makes it easy to allow more than one person within a certain group to have custom read, write, execute permissions to a file or directory. Then we see the file size in bytes. We could specify another flag to change the file size to be in other units, but the default is just in bytes. Next is the last modified date and time, and then finally we see the file name. Linux is pretty flexible about what characters you can use in a file name. You can even name a file starting with a dot, but there's a convention we follow for those. Files starting with a dot are cleverly called dot files. ls by default does not list those files, thus we tend to refer to them as hidden files. To see hidden files, or rather dot files, in the ls output, we need to add the -a for all option. You can see in this example what our home directory contains showing all files. It's quite a bit more than we saw earlier, right? Dot files are often used to hold configuration data for programs. For example, the .bashrc file holds customizations and configuration settings for the bash shell. When we launch a new shell, bash reads that file if it exists and changes its behavior according to whatever directives are in that file. Here's a little tip. To get to the user's home directory quickly, we can just type cd and hit return. It's like doing cd space tilde, but even shorter. Now we've seen a lot about the Linux file system. What directories are important, how to move around directories, and how to see what's in a directory. So go play around in your Cloud9 bash shell and see what's there. And we'll see you in the next section.